Mathematics, Grade 10, Monthly Review Mid-Year Exam. Powers and radicals. For any non-negative number a and integers m and n, radical a m index n is equal to a power m over n. Example, b power 2 over 3, 3 is an index, so radical b square index 3. Eight x squared minus 9y, all power 7 over 3. So the index is 3. Index is 3 and power is 7. We call nth root of any real number x, such that x power n is equal to a. If n is odd and a is any real number, then xn equal a. So x equal radical a index n. Example, x cubed equal minus 8. So x equal radical minus 8 index 3 equal minus 8 is equal to power 3. 3 with index radical index 3 equal minus 2. X power 5 equal minus 32. So x equal minus 32 index 5 equal 32 is equal to power 5. 5 with the radical index 5. So minus 2 the answer. If n is even and a greater than 0, then x power n equal a equivalent x equal radical a index n or x equal minus radical a index n. If n even and a negative, then a has no nth root. Example, x power 4 equals 16. So x equal radical 16 index 4. 16 is equal to power 4. 4 with the radical, so remains 2. And x equal minus radical 2 power 4 index 4 equal minus 2. We have two solutions, minus 2 and 2. Another example, x power 4 equal minus 16. So x equal radical minus 16 index 4. 4 is even, so it's impossible. No solution if uneven and a negative. X power 4 equal minus 16 has no solution. Now, vectors. Collinear vectors. Let u and v be a vectors. If there exists a real number k such that u equal kv, then u and v are collinear. If vector ab is equal to k times vector ac, then a, b, c are collinear. Midpoint of a segment. If I is midpoint of AB, then for every point O, we have OA plus OB equal to OI. Conversely, if there exists a point O such that OA plus OB equal to OI, then I is midpoint of AB. If G is a center of gravity of ABC, then for every point O, we have OA plus OB plus OC equal 3OG. Conversely, if there exists a point O such that OA plus OB plus OC equal 3OG, then G is center of gravity of triangle ABC. Coordinate system. Equality of two vectors. Vector v equal vector u. Let vector v of coordinate x, y and vector u of coordinate x prime, y prime. We said that the two vectors are equal if x equal x prime and y equal y prime. U plus v, factor u plus factor v, so we add the coordinate x plus x prime and y plus y prime. 3-point collinear. A coordinate x a y a, B coordinate x b y b, C of coordinate x c y c. We say that a b c are collinear if x a b over x a c equal y a b over y a c. X a b is equal to x b minus x a over x c minus x a equal y b minus y a over y c minus y a. How to find the length AB? AB is equal radical xb minus xa square plus yb minus ya square. Midpoint of a segment. Let I, xi, and yi be a midpoint of AB. Find the coordinate of I so that I is a midpoint of AB. As we know, 2OI equal OA plus OB. So, OI equal OA plus OB over 2. XI is equal to XA plus XB over 2. YI equal YA plus YB over 2. Center of gravity. Let A of coordinate XAYA, B XBYB, C XCYC, and G XGYG, and G is center of gravity. 3OG equal OA plus OB plus OC, so OG is equal OA plus OB plus OC over 3. Now X of G is equal XA plus XB plus XC over 3, while G equal YA plus YB plus YC over 3. Coordinate in new system. OM equal XO plus X prime along I plus YO plus Y prime along J. So new coordinate X equal XO plus X prime. X prime is a new coordinate. Y equal YO plus Y prime. Y prime is a new coordinate. O is new center. Trigonometry. Principal determination or the measure of an arc. Arc AB is equal to alpha plus 2k pi. Alpha between minus pi into pi. AB equals 37 pi, which is equal to pi plus 36. 36 is 2k pi, so cancel it. So alpha is equal to pi. Arc AB 25 pi over 4. 25 pi, it is 24 pi plus pi over 4. So 24 pi over 4 it's equal 6 pi plus pi over 4. But 6 pi is 2k pi. So alpha is equal pi over 4. Trigonometric lines on the trigonometric circle. As we know, x-axis is axis of cosine, y-axis is axis of sine. Cosine alpha between minus 1 and 1, sine alpha between minus 1 and 1. Sine square alpha plus cosine square alpha is equal to 1. Tangent theta equals sine theta over cosine theta. Cotangent theta equal cosine theta over sine theta equal 1 over tangent theta. Tangent theta times cotangent theta is equal to 1. Cosine square alpha equal 1 over 1 plus tangent square alpha. Sine square alpha equal 1 over 1 plus cotangent square alpha. Sine of trigonometric lines. Cosine axis, sine axis 0, pi over 2, pi, 3 pi over 2, and 2 pi. Sine here is positive, and here is positive. Here is positive, and here is positive. Here is negative, and here is negative. Here is negative, and here is negative. Example. Alpha between pi over 2 and pi. Sine alpha 3 over 5. Calculate cosine alpha and tangent alpha. First, we have sine. To find cosine, we have a relation sine square plus cosine square equal 1. So, cosine square plus sine square, sine is equal 3 over 5 square, 9 over 25 equal 1. Cosine square equal 1 minus 9 over 25 is equal to 16 over 25. But alpha between pi over 2 and pi. Alpha is between pi over 2 and pi. Between pi over 2 and pi, cosine is negative and sine is positive. So cosine alpha equal minus 4 over 5. Tangent alpha equals sine alpha over cosine alpha equal sine alpha 3 over 5, cosine alpha minus 4 over 5. So tangent alpha equal minus 3 over 4. Relation between trigonometric line of the opposite angle theta and minus theta. Cosine minus theta is equal to cosine theta. Sine minus theta is equal to minus sine theta. Tangent minus theta is equal to minus tangent theta. Cotangent minus theta is equal to minus cotangent theta. Supplementary angles theta and pi minus theta. Cosine pi minus theta is equal to, that's pi minus theta. Cosine is negative minus cosine. Sine pi minus theta is equal to sine theta, positive. Tangent pi minus theta is equal minus tangent theta. Cotangent pi minus theta is equal minus cotangent theta. Supplementary angles theta and pi plus theta. Cosine pi plus theta is equal to pi plus theta is equal to minus cosine theta. Here is negative. Sine pi plus theta is equal minus sine theta. Tangent equal tangent theta. Cotangent equal cotangent theta. Complementary angles theta and pi over 2 minus theta. Cosine pi over 2 minus theta equals sine theta. Sine pi over 2 minus theta is equal cosine theta. Tangent pi over 2 minus theta equal cotangent theta. Cotangent pi over 2 minus theta equal tangent theta. Exam review. Question 1. Simplify the following expression. A equal sine minus 15 pi plus x. It is minus 16 pi plus plus x minus sine 3 pi minus x, it is 2 pi plus pi minus x. Cosine 12 pi, cosine 12 pi, 12 pi is 2k pi. Cosine 17 pi, 17 is 16 pi plus pi plus x plus tangent 11 pi plus x minus cotangent pi over 2 minus x. Now 16 pi is 2k pi, 2 pi, 2k pi, 2k pi, 2k pi, in tangent k pi, cotangent pi over 2 remains, equal sine pi plus x minus sine pi minus x minus cosine minus x cosine pi plus x tangent x minus cotangent pi over 2 minus x equal sine pi plus x, draw a circle, pi plus x, that's pi plus x, so sine is minus sine x, sine pi minus x, that's pi minus x, sine is positive, so minus sine x minus cosine minus x is equal cosine x, cosine x, cosine pi plus x, pi plus x, cosine is negative, minus cosine x, tangent plus tangent x minus cotangent pi over 2 minus x is tangent x. Now tangent x minus tangent x equals 0, so the answer is minus 2 sine x minus 2 cosine x. B equal 2k pi or k pi in tangent and cotangent is equal to 0, 0, 0, and here 0. So B equal tangent x plus cotangent minus 5 pi over 2, it is minus 6 pi over 2 plus pi over 2 plus x plus tangent minus x equal tangent x minus 6 pi over 2, it is 3 pi, so it's 0. Cotangent pi over 2 plus x, tangent minus x, it is minus tangent x, so tangent x cotangent pi over 2 plus x, it is minus tangent x minus tangent x equal minus tangent plus tangent 0 minus tangent plus tangent 0, the answer is 0. Prove the following equalities. A 1 over sine square minus 1 over tangent square equal 1. So 1 over sine square x minus 1 over tangent square, it is cotangent, so it is cosine square x over sine square x equal same denominator sine square x, add the numerator cosine square x, 1 minus cosine square x, it is sine square x, and here sine square x is equal to 1. It is verified. B tangent x minus cotangent x equal 1 minus cosine square over sine x cosine x. First, tangent x minus cotangent x equal tangent is equal sine x over cosine x minus cotangent, it is cosine x over sine x equal Sine x times sine x, sine square x minus cosine x, cosine x, cosine square x, same denominator here, sine x, cosine x, equal, the answer 1 minus 2 cosine square. So sine square is equal 1 minus cosine square x minus cosine square x over sine x cosine x equal 1 minus cosine square 2 cosine square x over sine x cosine x. The answer is verified. Number 3. Simplify radical 1 plus sine alpha radical 1 minus cosine alpha times radical 1 minus sine alpha radical 1 plus cosine alpha equal, under same radical 1 plus sine alpha 1 minus sine alpha radical 1 minus cosine alpha 1 plus cosine alpha equal, it is in the form a plus b and a minus b is equal 1 minus sine square alpha radical 1 minus cosine square alpha. So the answer is 1 minus sine square, it is cosine square alpha over radical sine square alpha. But we have alpha between 0 and pi over 2. So alpha between 0 and pi over 2. So cosine alpha is positive and sine is also positive. And sine alpha is positive. Then cosine square alpha, sine square alpha is equal to sine alpha. Cosine alpha over sine alpha, it is cotangent alpha. B, sine x plus cosine x equal radical 2 minus 1. Calculate sine 7 pi minus x plus cosine 6 pi plus x equal, sine 7 pi minus x, it is sine 6 pi plus pi minus x. Cosine 6 pi, it is 2k pi, cosine x equal 2k pi sine pi minus x plus cosine x. Sine pi minus x, pi minus x. Sine is positive, so it's equal sine x cosine x. Sine x plus cosine x, it is given, equal radical 2 minus 1. 2. Prove that sine x times cosine x equal 1 minus radical 2. First begin from remarkable identity. Sine x plus cosine x square equal sine square x plus 2 sine x cosine x plus cosine square x. Sine x plus cosine x, it's equal to radical 2 minus 1 and your square equal sine square plus cosine squared is 1 plus 2 sine x cosine x. 1 plus 2 sine x cosine x equal radical 2 minus 1 square. 2 sine x cosine x equal radical 2 minus 1 square minus 1. 2 sine x cosine x equal radical 2 minus 1 square. Use remarkable identity. 2 minus 2 radical 2 plus 1 minus 1. 2 sine x cosine x equal 2 minus 2 radical 2, since 1 and minus 1 0. Sine x cosine x equal 2 minus 2 radical 2 over 2. Then sine x cosine x equal 1 minus radical 2 over 1. Sine x cosine x is equal 1 minus radical 2. Tangent x equal minus 3 over 4, and x between pi over 2 and pi over 2 and pi. If x between pi over 2 and pi, then cosine is negative and sine is positive. Cosine x negative, sine x positive. Let's begin. Part A. Find the exact value of cotangent x. Cotangent x equal 1 over tangent x. So it's equal minus 4 over 3. Sine square x equal 1 over 1 plus cotangent square x equal 1 over 1 plus cotangent square x. Cotangent is equal minus 4 over 3. Minus 4 over 3 square equal 1 over 1 plus 16 over 9. So it's equal 9 plus 16, 25 over 9 equal 9 over 25. So sin x equal plus or minus radical 9 over 25. But sin x is a positive. Sin x is a positive. So sin x equal 3 over 5. Now cosine x. We know that cotangent x equal cosine x over sine x. So cosine x is equal cotangent x times sine x equal cotangent is equal minus 4 over 3 times sine x 3 over 5. So the answer is 3 by 3 minus 4 over 5. B. E equal 3 cotangent x plus 6 sine x plus 2 cosine x. So 3 cotangent x is equal to minus 4 over 3. 6 sine x is equal 3 over 5. 2 cosine x is equal minus 4 over 5 equal 3 by 3 minus 4 plus 6 times 8, 18 over 5 minus 2 times 4, 8 over 5 equal minus 4 plus 18 minus 8, 10 over 5 equal minus 4 plus 2 equal minus 2. Question 2, number 1, part A. 9 power n plus 2 plus 3 power 2n plus 1 over 3 power 2n minus 1, 3 power 2n plus 1, 3 power 2n. First, 9, it is 3 square. 3 square power n plus 2, it's equal 3 power 2n plus 4. 3 power 2n plus 1 over 3 power 2n minus 1, 3 power 2n plus 1 minus 3 power 2n. Take a common factor, 3 power 2n. 3 power 4 plus 3 power 1. Here 3 power 2n common factor remains 3 power minus 1, 3 power 1 minus 1 equal 3 power 2n, 3 power 2n cancel. 3 power 8, 3 power 4, it is 81 plus 3 power 1, 3 over 3 power minus 1, 1 over 3, plus 3 minus 1, 2, equal 84 over, same denominator here, times 3, so the answer is 6, 7 over 3, equal 252 over 7. 202 over 7 is equal 36. B. 4 power 2 over 3 times 6 power 7 over 3 all over radical 4 index 3 times 9 times radical 3 index 3 equal 4 is equal to square 2 square 2 power 4 over 3 times 6, it is 2 times 3, so it is 2 power 7 over 3 times 3 power 7 over 3. 4 it is 2 square and index 3 2 square over 3. 9 it is 3 square. Radical 3 index 3 it is 3 power 1 over 3 equal 2 power 4 over 3 times 2 power 7 over 3 times 3 power 7 over 3 times 2 power 2 over 3, 2 power minus 2 over 3, 3 power minus 2, 3 power minus 1 over 3 equal same base 2, add the numerator, add the power 2 power 4 over 3 plus 7 over 3 minus 2 over 3 times 3 power 7 over 3 minus 2 minus 1 over 3 equal 2 power 4 over 3 plus 7 over 3 minus 2 over 3, it's equal to 3 times 3 power 7 over 3 minus 2 minus 1 over 3 is equal to 0 equal 2 power 3 is equal to 8. 3 power 0 is equal to 1. 8 times 1 is equal 8. Solve. X minus 1 power 3 equal minus 8. So x minus 1 equal minus 8 index 3. X minus 1 equal radical minus 2 power 3 index 3. X minus 1 is equal to minus 2. X equal minus 2 plus 1, x equal minus 1. We have one solution since the index is odd. Now B, x cubed minus 2 all power 4 equal 81. X cubed minus 2 equal radical 81 index 4 or x cubed minus 2 equal minus radical 81 index 4. Since the index is even, we have two solutions. X cubed minus 2 equal 81 3 power 4. X cubed minus 2 equal 3. X cubed equal 3 plus 2. X cubed equal 5. So x equal radical 5 index 3. X cubed minus 2 equal minus radical index 4 81. 81 is 3 power 4. So x cubed equal minus 3 plus 2. X cubed equal minus 1. X equal minus 1 index 3. Now see, absolute value x minus 2 less than 5. So x minus 2 is between minus 5 and 5. Add 2, add 2, add 2. minus 3 less than x less than 7. So x is between minus 3 and 7. X belong minus 3 and 7. Open since without equal. D, x plus 4 greater than 2. So x plus 4 greater than 2, x plus 4 less than minus 2. X greater than 2 minus 4, x greater than minus 2. X less than minus 2 minus 4, so x less than minus 6. The interval is minus 6 minus 2. Minus 6 less than minus 6 here. Greater than minus 2 here. Without equal, without equal. So x belong from minus infinity to minus 6 union from minus 2 plus infinity. Question 3. Consider the system OIJ. Coordinate A, B, and C. Calculate the coordinate of vector V equal to AB minus 3AC. First, find the vector AB. AB is XB minus XA, YB minus YA. So AB vector, the XB minus XA, 0 minus minus 2 plus 2, YB 2 minus YA 1. So AB vector is 2, 1. Now AC vector. AC vector XC minus XA, YC minus YA. AC vector XC is equal minus 1, XA minus 2 become 2, YC 3 minus YA 1. AC vector is 1, 2. So vector V, x of vector V equal 2xAB minus 3xAC equal 2xAB is equal to minus 3xAC 1 equal 4 minus 3 equal 1. XYV equal 2YAB minus 3YAC equal 2YAB AB 1 minus 3YAC 2 equal 2 minus 6 equal minus 4. So the vector V of coordinate 1 minus 4. 2. Prove that ABC determine a triangle. X of AB over XAC equal YAB over YAC equal XAB is equal to 1 over 2 over 1 equal to YAB 1, YAC 2. Notice that XAB over XAC does not equal YAB over YAC. So A, B, and C are not collinear. So deduce that A, B, and C determine a triangle. 3. Calculate the coordinate of the fourth vertex of ABCD. If ABCD parm, ABCD parm, so vector AD equal to vector BC. XD minus XA equal XC minus XB. XD minus XA is 2. XC minus 1 minus XB 0. XD equal minus 1 minus 2 xd equal minus 3. Now yd minus ya equal yc minus yb. yd minus ya 1, yc 3 minus yb 2, yd equal 3 minus 2 minus 1 plus 1, yd equal 3 minus 2, 1 plus 1, 2. So the coordinate of D is minus 3, 2. 4. Calculate the coordinate of A and B in new system. XA equal XD, new system of center D, XD plus X prime A. So XA is equal minus 2 equal XD, D of coordinate minus 3, 2. XD minus 3 plus X prime A. So X prime A is equal minus 2 plus 3 equal 1. YA equal YD plus Y prime A. YA is equal 1 equal 2 plus Y prime A. So Y prime A is equal 1 minus 2 equal minus 1. So A of coordinate 1 minus 1 in the new system D, I, J. Now coordinate of B, XB equal XD plus X prime B. 0 equal minus 3 plus X prime B. So X prime B is equal to 3. YB equal YD plus Y prime B. 2 equal 2 plus Y prime B. Then Y prime B is equal to 0. New coordinate of B is 3, 0 in new system D, I, J. 5. A center of gravity of ABC. So XM equal XA XB plus XC over 3. XM 2M plus 1 equal XA is equal to minus 2, XB 0, XC minus 1 over 3. So 2M plus 1 equal minus 3 over 3. 2M plus 1 equal minus 1. 2M equal minus 1 minus 1. 2M equal minus 2. So M equal minus 2 over 2 equal minus 1. YM equal YA plus YB plus YC over 3. YM 2N plus 4 equal YA is 1, YB YC over 3. 2N plus 4 equal 3 over 3, 3 plus 3, 6 over 3. 2N plus 4 equal 2. So 2N equal 2 minus 4. 2N equal minus 2. N equal minus 1. B. Find a relation between M and N if the vectors AM and 3AB are collinear. First, find the vector AM. It is XM minus XA, YM minus YA. So AM, XM is 2M plus 1 minus XA plus 2, YM 2N plus 4 minus YA minus 1. AM is 2M plus 3, 2N plus 3. Now, vector AB, it is 2 and 1. We calculate it. 3AB is 3 times 2, 6. 3 times 1, 3. AM and 3AB are collinear if x AM over x of 3AB equal y of AM over y 3AB. XAM is 2m plus 3 over 6 equal 2n plus 3 over 3. Cross multiplication, 6m plus 9 equal 12n plus 18. So 6m plus minus 12n equal 9. This is a relation. Question 4. ABC be a triangle. Any triangle A, B, C. I point of B, C. CD is equal to half AB and DE is equal to half of AC. BE is equal to half of AC. J is a midpoint of ED. J. Prove that BE plus CD equal AI. BE plus CD equal AI. First, BE is equal to half AC. BE equal half AC from given. CD is equal to half AB. Half AB. So, take a common half. AB plus AC plus AB equal half AC plus AB. AB plus AC is equal to AI. 2AI. Since I midpoint of BC. 2AI. 2 by 2. So is equal to AI. Verified. Now BE plus CD equal 2IJ. Begin from BE. BE is equal BE plus CD equal. BE is BI IJ JE. BI using Chasley's rule IJ plus JE plus CD is equal CI IJ JD. CI IJ JD equal BI plus CI BI plus CI is equal to 0. JE plus JD JE plus JD is equal to 0. So equal to IJ. BE plus CD equal to IJ. Now deduce that AI equal 2 over 3AJ. We have BE plus CD equal I from part 1 and BE plus CD equal to IJ. So we conclude that AI equal to IJ. Want a relation between AI and AJ. not ij. So ai equal 2ia plus aj using Chassis. ai equal 2ia plus 2aj. So ai minus 2ia equal 2aj. ai minus 2ia plus 2ai equal 2aj. ai 2ai 3ai equal 2aj. So ai equal 2 over 3aj. What does I represent for triangle ADE? I, center of gravity of triangle ADE. Since AI equal 2 over 3aj. Let K be a point such that 5Ki minus 2Kj equals 0. Part A. Prove that Ik equal 2 over 3Ji. Ki, Kj, 5Ki minus 2 Ki plus Ij equal 0. 5Ki minus 2Ki minus 2Ij equals 0. 5Ki minus 2Ki, 3Ki equal 2Ij. So minus 3Ik equal minus 2Ji. Then we can conclude that Ik equal 2 over 3Ji. So this expression is verified. What can you say about I, J, and K? We have a relation between I, K, and J, I. So we can say that I, J, and K are collinear. Now, let M be any point in the plane of the triangle. Express 5mi minus 2mj in terms of mk. 5mi minus 2mj equal 5 in terms of mk, k here and k here. So 5mk plus ki minus 2mk plus kj, 5mk, 5ki minus 2mk minus 2kj equal 5mk minus 2mk, 3mk, 5ki minus 2kj. As we know, 5ki plus 2 minus 2kj is equal to 0. So 3mk plus 0, so it's equal to 3mk.